It is my pleasure to introduce today's speaker, Owen Garrett, Head of Products and Community here at Deepfence. With that, Owen.
Thank you, Michelle. And everybody, welcome to the webinar. Today, we're going to talk and explore some of the ways that shift-left practices within development and DevOps can be reflected within our operations teams. Shift-left allows our development teams to push code that is believed to be secure into production. But after that, the burden of responsibility sits with the ops team to monitor and manage the production environment and ensure that the security is maintained. What can we do to close the loop, to reconcile some of the differences between those different teams and ensure that the whole process works smoothly and effectively? By way of introduction or beginning, let's just reflect on the challenge that we're facing with modern applications. When I started in this industry, and perhaps when some of us did, security was a lot simpler. We knew where the application was. We knew what the boundary of the application was. It was often some big J2EE blob running on a physical server with well-defined boundaries. We could put a network firewall in front. We could put the right monitoring tools in place and then let it run and watch it. Modern applications face much greater security challenges. Securing a modern application is much more like trying to secure an entire city, where you don't always know what assets and resources are running inside the city, what buildings, what businesses, what people are there, where the city's constantly changing. It has an open perimeter, so a very, very broad attack surface. And as developers push more and more code into our city and attackers roam around looking for ways to infiltrate and spread their influence, the job for us as security professionals is to keep this city safe for our applications and the services that run within, to discover and understand what's running inside this city, to annotate it with vulnerabilities so we know where the risks lie, and then to watch what's going on, the activity of users and traffic within that city, anomalies and strange behavior within applications, and to piece that together to identify if an attack is unfolding, if a risk threshold has been met, and deploy targeted defense when needed. That's what Deepfence does with our two products, the ThreatMapper open source security observability platform. This gives you an at-the-time view of the status of your city, of your applications. And then in another webinar to follow, we'll delve into ThreatStryker, which is the real-time capability of tracking activity inside the city and securing and blocking attacks as they happen. So today we're going to look at ThreatMapper, and we'll start by looking at the problem that Deepfence ThreatMapper is designed to address. Many organizations have invested very heavily in shift-left initiatives. They're using CI/CD processes and scanning inside CI/CD to ensure that only secure code free of vulnerabilities, finds its way into production. Automating processes, running infrastructure as code or GitOps processes to help make reproducible, safe, auditable processes. Shift-left initiatives that are performed by your dev and DevOps team answer the question, am I deploying secure code into production? But they don't answer the question, is that code still secure? Are the applications still safe? Are they under attack? Where traditional shift-left initiatives stop, that's when Deepfence and Deepfence ThreatMapper pick up. Why do we focus so heavily on shift-left projects? A very, very valuable, sensible, security-focused approach, but one that the burden of responsibility sits with the development team. The reason this is so important is that modern applications are built on enormous stacks of third-party code, typically open source third-party components written by teams that you and I don't even know Yet when we push that application into production, we have to take on the responsibility for the security of that code. And as vulnerabilities are discovered in third-party dependencies, those vulnerabilities can pose areas of exploit or attack against our applications. The number of vulnerabilities is increasing. Over 18,000 CVEs published last year, and we're on track to exceed that number by the end of this year. Over 50% of these open source vulnerabilities in dependencies that the application is built on are rated high or critical. And typical enterprise applications have a great number of such dependencies. Synopsis's report suggested there were over 500 on average open source dependencies that are linked in and are used by an application, and that well over 80% of those dependencies had at least one published known vulnerability. And so the thinking in the industry has been that when you find a problem in a piece of code that needs to be remediated, it is so much more effective and cheaper and lower cost to remediate that problem early in the development cycle rather than late. As a result, we've created a set of solutions called Shift Left. They push the burden of securing code leftwards towards the development and DevOps team. And there's a huge ecosystem of very effective tools that center around code analysis and code scanning that make sure that when that code is completed and is ready to be deployed into production, the number of vulnerabilities is reduced to a minimum, and those that remain are well understood and well audited. But if we put too much faith in Shift Left and we take our eye off the ball of the security of our applications in production, we face some great risks. I grew up in Northern Ireland, very close to the Harlands and Wolff shipyards that built the Titanic. The start of the last century, they were one of the most prestigious, effective, and advanced shipyards in the world. The Titanic was one of the biggest, most opulent, most complicated projects that they ever undertook. And we all know the tragic story of the Titanic on its maiden voyage, with the rush to break the records for transatlantic crossing, the incident with the iceberg, and the rest is history. This was a little bit of a Shift Left problem. And if you speak to anybody in Northern Ireland, there's immense pride about what happened, the quality of the engineering, the quality of the ship that was built. And any Northern Irish citizen will tell you she was fine when she left us. This is the putting faith in Shift Left problem. The code was fine when it was pushed to production, but our AppSec teams are wondering, how do I know whether it's still secure? And these are real risks. Vulnerabilities can take a long time before they're discovered. GitHub survey of the code bases managed on GitHub indicate that on average it takes 4 years to discover a vulnerability in a piece of code that's been published, and a further 12 weeks to go through the process of triaging, understanding, fixing, and publishing a fix to that vulnerability. That means that vulnerabilities can appear in production code at a moment's notice. This has tripped up organizations such as Equifax, who were impacted by the Apache Struts vulnerability a few years ago. And although they moved to patch their their applications as they moved into production with code that resolved that vulnerability, they had no means, or they did not go back and look at in-production applications at that time. And 2 months later, an attacker found a fleet of such applications exposing the Struts vulnerability, and were able to leach over 143 million customer records from the Equifax systems, resulting in a bill of over $1 billion of remedial action on Equifax in order to improve the security of their applications. And just a month or two ago, a similar issue, over 100,000 Apache web servers were found to be vulnerable to a critical path traversal exploit that would allow an attacker to access any file on the file systems that the Apache server could see. Those are all services that are running in production. Vulnerabilities appear after they've been deployed, or maybe they're services that have not been quizzed and scrutinized by your shift left security pipeline. They've been pulled from other sources. But the shift left tools that your DevOps teams use, they end. They stop managing the code once it's moved into production. When Red Hat surveyed their OpenShift Kubernetes users and asked them what security incidents or issues have they found in production over the last 12 months, 94% of their users were prepared to acknowledge that they had experienced at least one security issue in their Kubernetes environment in the last 12 months. And so, how do we align the activity and the KPIs of Dev and DevOps with that of the app security team? Our development teams are iterating as quickly as possible to bring new features to market, and they want to automate everything that can possibly be automated so that they only need to focus on the key value-add activities. Asking them to prioritize and investigate long lists of potential vulnerabilities is something that just cannot easily be integrated within a typical DevOps cycle. Yet on the other hand, our AppSec team, they're responsible not for individual applications, but for the security of our entire infrastructure, all of the applications that have been published, and the requirement to have consistent security standards across each. They look infrastructure-wide. They spend time doing activities such as threat hunting, exploring, trying to find weaknesses that have found their way into production or have just been uncovered, and typically can turn up tens of thousands of potential vulnerabilities across an infrastructure, hundreds of vulnerabilities per host, dozens of vulnerabilities per container. Of course, it'd be great if there was a magic wand that we could wave that just patched all of those vulnerabilities and made them go away, but we can't do that. We have to pass that back to the engineering team to hunt for a fix, to QA it, and then to push it back into production. The AppSec team probably see the development team as being slapdash, not paying enough attention, looking at theoretical security vulnerabilities, whereas the development team feel they haven't got enough context, they haven't got enough prioritization. And so in order to reconcile these two teams and get them aligned, we need a way of discovering vulnerabilities in production, vulnerabilities that are open to exploit, at the highest risk of exploit, and prioritizing those vulnerabilities and feeding them back in a way to the development team that the development team can then operate on, resolve, and push fixes back into production. How can we do this? How can we align the shift left processes that our dev team does with the production security? And that's where Deepfence and Deepfence ThreatMapper comes in. We're one part of the security toolkit. We focus on detecting vulnerabilities in runtime, and then with ThreatStryker, our enterprise product, also protecting against runtime events and attacks in progress. And today we'll focus on the vulnerability detection that ThreatMapper offers, the ability to discover the vulnerability map of your applications. The Deepfence approach addresses your runtime environments, and it maps out the topology of those environments, identifies the services within, identifies the vulnerabilities, and prioritizes them based on risk of exploit. And by doing so, reduces tens of thousands of in-production issues down to a much shorter list of just 5 or 10 of greatest risk of exploit. I'd like to give you a quick demo of the ThreatMapper product running. There are two components. We'll begin with the management console. This is a standalone GUI and API-based tool that takes and converges all of the information and makes the calculations to identify the most significant vulnerabilities. And it does so by taking telemetry and data from Deepfence sensors, which are deployed within production environments. We'll deploy the management console in a Docker environment. We'll spin it up. I'll show you how to do that. And then we'll deploy a sensor in a Kubernetes environment so you can see how the two work together. ThreatMapper is entirely open source. And we're going to start by deploying the management console. The management console on Docker is deployed with a simple Docker compose file. So let me find, here we go. So here I've got a shell on an Ubuntu machine running a DigitalOcean. And I'm going to grab our Docker compose file. There we go. And then I'll run Docker compose to spin the console up. Docker has cached all the container images, so it will spin and start those images pretty quickly. It can take typically 30 seconds to a minute for those container images to get up and begin initializing. And as we'll see in a moment, once the management console begins, we'll log in, we'll register for an account, and we can register services against that management console, but it will also sit in the background, pulling in threat feeds from a range of different sources. It does that to build up our threat database so that we can then perform our vulnerability scan. Let's just grab the IP address. So it's this one here. And if I bring up a new tab, hit that. So it takes, as I said, about 30 seconds to a minute. So we'll give that a moment to load. We have the process running. Okay, so I'm going for about a minute, and here we are. So this is a new install. From previous tests, it's cached my credentials, so I need to register again. The first user who accesses gets the option to register, and then, oops, let's stick something at the end of that. First user who registers gets the option to register online, and then subsequently other users are added through, on the user management page, through an invite from the first user. We can look at our topology, and you can see our DigitalOcean environment. We have a server running in London. Here's the virtual machine running Docker, and you can see the processes which are running, the communications they're making. And in fact, you can even see down to the detail of our CVE check tool pulling threat feeds from various different sources. What we're going to do, first of all, is we're going to register a Kubernetes cluster with this system. So to do that, I need to grab the API key, so, and then here I have a machine with Helm and kubectl pointing at a Docker cluster, at a Kubernetes cluster, and I'm going to deploy the Deepfence agents on that Kubernetes cluster. They will then call back and talk to our management console. So having followed the instructions for installing the management console, let's now jump down and let's add Deepfence repo to our management machine, and we're going to install it. So I'll use this. Remote services are authenticated using the API key that I just copied. Whoops. Let's just do that again. So let's grab our API key here. And of course, we also need to put the IP address in of the console so that the agents know where to phone back to. And having done this, this will then deploy the Deepfence sensor agents onto our Kubernetes cluster. So if we see them going. So, okay, so we have the agents running. I'll now come back to my topology chart, and let's just move that. Let's take a look at DigitalOcean, and we've now got a Kubernetes cluster rendered inside our Deepfence management console. It has 3 nodes. On those nodes, ThreatMapper has discovered there are a series of pods running, communicating with each other. And we can pick one of these nodes and we could kick off a vulnerability scan. So I could select all packages, scan an entire cluster and get started. This vulnerability scan takes the time to complete, and really you should wait until ThreatMapper has reported that it's downloaded the entire feeds. So let's go and take a look at one that I've installed earlier. Here is our demo system. This has been running for some time. Threat feeds are fully up to date. And again, we can zoom in and look at the assets that are running. So we can look what's running on NYC1. We have a host called DigitalOcean Agent. We have a number of different containers on that. We can see the flow. So we can see traffic hitting an Nginx worker process from the internet, passing through to an Apache server, to MySQLD. And as you can see, we ran a vulnerability scan against this a little while ago. So we have a large amount of telemetry and information showing what is happening, what are the extant vulnerabilities on this system. Let's look at some of the vulnerability scans that ThreatMapper has run on this system. We've run scans against host environments. So we have a GCP host. This is a virtual machine, relatively safe. We've run scans against various different container images as well. So if we were to pick, say, this one at the bottom, there's a huge amount of useful data here. I can delve in and look at this container running in production, and I can see what are the issues that have been found. 4 critical issues on that container. We can jump in and look at one of those issues specifically and see what's the attack vector. This is a network accessible exploit of a low complexity. What package caused the CVE? Get some metadata around the CVE itself. So an issue with Netkit Telnet. It's been fixed in a particular update, and we have a link through to the full security, the full CVE link, if we wish. Let's let Debian do its thing. We also have an attack path for that CVE. This container is directly connected to the internet, so a network exploitable attack is very, very easy to mount by an attacker. The number of vulnerabilities that you see can be huge. Let's drill back and grab our summary. In this system, a small lightweight system, we've seen over 1,000 vulnerabilities, containers with huge numbers of vulnerabilities, many of which are of low priority, hosts with vulnerabilities. How can you thin this down and identify what are the key issues that you need to address? That's where the most exploitable vulnerabilities calculation comes in. ThreatMapper doesn't just rank vulnerabilities. ThreatMapper also looks at how that vulnerability can be exploited, and are there potentially active paths that may be able to exploit that. Here we begin with live connections going to a number of medium and low priority CVEs. This is the highest priority, something we may want to look at right now. But as we reflect, the real meat comes when we look at the critical vulnerabilities. These have been sorted after the live ones in order of risk and potential of exploit. It's illustrated here in our attack path. From the internet, in this case, we've identified 3 resources or 3 attack paths. One which goes through multiple different hops in order to hit our MySQL server, with CVEs that we have assessed are at highest risk of exploit and have highest potential impact. You can take this information and you can either feed it automatically through a series of integrations to alert to your team, or you can zoom in and look just at those critical vulnerabilities and get the data that you need to feed back to your engineering team to ask them to prioritize those top 5 or 10 vulnerabilities in the applications that you're running in your environment. So that gives us a very, very quick whistle-stop tour of what you can do with Deepfence ThreatMapper. Completely open source, ready to install and use now. And it provides the vulnerability detection that we've seen, the ability to build a threat map and to give you that actionable list of most exploitable vulnerabilities so you know what you need to fix first. There's much more goodness within the Deepfence technology stack. And in following webinars, we'll look at some of the runtime capabilities that we offer. Whereas the vulnerability management gives you a static at the time report as to where the weaknesses are within your city of applications, the runtime telemetry tells you in real time what is happening within that city. On the box indicators of attack, or indicators of compromise, network indicators of attack, so you can understand how attackers are seeking to compromise your application and data. And we put that information, what's happening on your system, together with the vulnerabilities that we have found and understood, in order to present information around the attacks which we believe are unfolding within your application right now. The reconnaissance traffic, the doors that it's knocking on, the exploits that are beginning to be successful as the recon traffic hits containers and workloads with matching vulnerabilities. The delivery of attacks, lateral spread, installation of command and control, and exfiltration. We observe the evolution of attacks as they unfold, and when they hit a threshold of your choice, we can apply automated or guided remediation in order to neutralize that attack, to firewall off the source of attack traffic, or to quarantine the potentially compromised container. So in summary, starting with ThreatMapper, the open source platform, this gives you the tools that you need to identify vulnerabilities in your applications and to feed those back to the development team in a way that they can act on, with clear, prioritized targets for vulnerabilities that need to be closed. Supporting multiple clouds, multiple environments, multiple types of workloads, virtual machines, containers, Kubernetes, and serverless, as we've seen, and spanning those clouds. If you want to get started with ThreatMapper, as you've seen, installation is very quick and straightforward. You'll find what you need on GitHub, Deepfence/ThreatMapper, completely open source, Apache licensed, and we'd be very happy to provide you with help and support on Slack, through GitHub issues, or other means. So getting up and running with ThreatMapper and finding vulnerabilities in your applications in production is very, very quick and easy to get going with. If you'd like to find more about our ThreatStryker product, the product that then applies the runtime telemetry and watches attacks as they unfold, matching that against the threat map built by ThreatMapper, then come and talk to us. Find us at deepfence.io. We would love to present a demo to run through with your requirements, understand, explain to you how ThreatMapper, how ThreatStryker may be able to help, give a trial, help you through a managed proof of concept. And of course, in a follow-up webinar, we'll go through ThreatStryker in much more detail. So thank you for your time. I hope that what we've shared with ThreatMapper is relevant, useful, and intriguing for you. We'd love to see you on GitHub or on our Slack channel if you get a chance to give it a go. Shift left, deploy secure applications, but don't forget to secure right.
Awesome. Thank you so much for the presentation today. With that, we are now at the Q&A portion of today's webinar. So if you have a question, we would love to answer it. You have the Q&A box down at the bottom of your screen where you can ask questions with your name attached or anonymously. Okay, there is a question in here that I would like to read aloud, and then Owen would love if you could answer that for us today.
Sure.
I saw in the demo that DigitalOcean and GCP are supported. Does ThreatMapper support other clouds?
Absolutely. Great question. And we've built ThreatMapper from the ground up to be lightweight. And as a net result, it's fairly cloud agnostic. The ThreatMapper agents can be deployed on any Kubernetes environment, so self-hosted or cloud-hosted, and we support those. So GKE and AKS, EKS, we support those, deployed on your own Kubernetes environment, deployed within Docker environments, deployed with serverless in Amazon Fargate, and also deployed as processes within a virtual machine or a bare metal environment. So there's a very broad base of support. You deploy your agents on the workloads you wish to monitor. You saw when I did that for the Kubernetes environment that it's really straightforward. You give them the authentication key, you give them the destination for the management console, and they'll begin to quietly sit in the background and to feed back information to the management console so that we can then start vulnerability scans and monitor traffic. And the console then surfaces that. We have users with hundreds, thousands of nodes monitored from a single console. The console does a great job of surfacing that. It gives you an interactive tool where you can drill in and see the traffic that's flowing and the resources that you have deployed.
Okay, awesome. Another question has come in here. We are already doing scanning in CI. How does Deepfence differ from the other scans we're already doing?
Yeah, this is again, it's quite a common question. And I've talked to a number of customers who've said that, or users who've said that my DevOps team does scanning at CI, so isn't that sufficient? Scanning at CI is a really important step because that ensures that the code you push into production is as secure as it possibly can be. But risks can emerge that you didn't anticipate at CI. So if we think of the Equifax example, they deployed their code into production unaware of the Apache Struts vulnerability. When that vulnerability was disclosed after the code had been deployed into production, then they were at risk of being exploited. So first, vulnerabilities can appear and be disclosed after code's been pushed into production. Secondly, code can be pushed into production without going through your CI process, without being scrutinized by your code scanners, by SNCC or the like. If you pull things off Docker Hub, if you have monitoring agents from third parties, if your infrastructure deploys additional services, that may not be scanned by your CI process. So you can be running services in production that haven't been fully scanned for vulnerabilities. And finally, it's not always possible to close off every single vulnerability before you pass code into production. And I'm sure you've come across this. You've run your code through the CI system, it's flagged up dozens of potentially vulnerable packages, and you've had to make a pragmatic, educated decision that it's just not worth the time trying to resolve these issues, find fixes, and retest. You make the decision that you need to move fast, that these issues are probably not exploitable, and so it's not uncommon to have containers in production with vulnerable packages where the user has made a deliberate decision that the risk that those packages offer is not enough to interrupt a CI process. That happens, and you need a way to track what containers are running in production, what vulnerabilities exist, even if you've made a decision at that point that it's safe to deploy those into production. And ThreatMapper will inspect those vulnerabilities, will inspect the vectors, and will factor that in to the vulnerabilities at greatest risk of exploit report.
Okay, that's the last question that's come in from the audience. Owen, thank you so much for your time. Everyone who's attending today, also thank you so much for your time. Any closing comments, Owen, before we wrap up?
There's a great series of webinars coming. My colleague Sham will do a deep dive into the capabilities in ThreatStryker in the following webinar. And please do check out our YouTube channel and GitHub, where you can get a simple, quick introduction to ThreatMapper to help you get started.